Is it recording? It's recording. Okay. Let's record the screen. So, fill out this form, get attendance credit, and upcoming deadlines. Project 1B is due this Friday, I believe. So, do that. It's a pretty short and sweet project. Yeah. And then, midterm 1 is on Valentine's Day. It's a great way to spend your Valentine's Day. And, yeah, so, exam prep section. My website is up there. It's vivian.tk/cs61b. You can email me at v.fang+61b@berkeley.edu. The +61b just chucks your email into a folder, so it's more organized. But yeah, let's get started. Just get right into it. So exam prep sections, we're not going to do any review. We're just going to jump into a problem. So this is problem 1. And the way that I would like you guys to sort of work on it is to you can treat it like a group quiz right now because I'm not giving you as much time as you would have on an exam, so you could work with people that are next to you, or you can work by yourself, that's fine too. So this is the question. I'll give you guys about 8 minutes, so you'll have until 5:20 to do this. And I think that's a good amount of time. Alright, let's go over it. So this is a very straightforward, I'm going to make an int list, I'm going to play around with its pointers, and then I'm going to ask you what it's going to print. So for these kinds of questions, it's a really good idea to draw your box and pointer diagram so that you keep track of everything in your head. So let's start with the statement. So I've already drawn A, which is an int list with 5 that's pointing to nothing. So it's just like a list that's 5. Okay. And then now it says system.out.println a.head. What is a.head?
5.
Yeah, prints 5. Okay. Oh, it's a private variable. Okay. So we're gonna. This is probably oversight, I guess, but we're gonna treat it such that we can access it, or else this whole question would be like error. You know what I'm saying? So let's pretend this was inside here or something. Sorry. Okay, this is or let's just pretend these are public. Whoops. This is public. Okay. We're gonna treat head and tail such that we can access them. It's not gonna be like error. But a.head is 5. Yeah? Okay. So then now we make a new int list called B. So what goes in the first box? 9 and null. Alright. So 3 statements, pretty easy so far. And then now we start with int list C equals new int list 1 comma new int list 7b. So C is going to be pointing to first a 1. And then this box is going to be pointing to what? Right. Whatever is inside that new int list, which is a 7. And what is this pointing to? Right. It's pointing to whatever B is pointing at, which is right here. Are we good so far? Okay. So then now we start actually modifying the pointers. Now we're saying a.tail equals c.tail. So what is a.tail? Right, a.tail is this box right here. A big sort of misunderstanding some people have is that maybe they think a.tail is actually null, whereas a.tail is actually the box that holds that value null. So when you change a.tail, you're changing whatever that box value is. So in this case, we're going to make a.tail equal c.tail. And what's c.tail?
7.
Right, it's the int list with 7. Okay, so we're good so far. Now let's look at, we can do different colors. All right, so this is gonna be from green. We'll make this one red. Okay, a.tail.tail equals b. What's a.tail.tail? Right, it's right here. So it actually does nothing because it's already pointing whatever b is pointing at. But we'll just draw it in red for redundancy. Okay. So that's what it's actually doing. It still reassigned this to be whatever B was pointing at, but because it was already the same thing, your pointers didn't really change. Okay. And then now we have b dot tail equals c dot tail. So what is b dot tail? Right, it's this box. Right, it's this box. And what is c dot tail? Right, it's a box that's pointing, or it's like, it's here. Okay. Are we okay? Alright, so then, now we're going to make a new int list called int list d. And d is going to have this value 9002. And it's going to point to b dot tail dot tail. So again, we have to kind of count the tails. So b dot tail dot tail. So it's pointing to the int list with 9 in it. Okay. Whee. All right. So it's starting to get pretty ugly. But that's okay. So then now let's look at the next line, which is print d dot tail dot tail dot tail dot head. So we have to evaluate all of our tails, right? So if I'm going to d, this is d dot tail, this is d dot tail, and then this is d dot tail dot tail dot tail, and the head is 9. So if you're trying to count tails, just count like the pointers. So here it's like, if there's 3 tails, it's 1, 2, 3, and then you take the head. Okay. And then now we have to print out a dot tail dot head. So a dot tail dot head, which is 7. Okay. And then now we do another assignment. I don't have any more colors. Oh, wait, I do have more colors. Okay. So now we're going to say c dot tail equals c dot tail. So what is c dot tail? What box is it?
Red box.
It's this red box. And we're gonna point it to be c dot tail. Right? So c dot tail is gonna be c dot tail. So it's gonna like point to itself. So and now we just kind of erase these. So this is what we got. And now it's gonna ask for system.out.println a dot tail dot tail dot tail dot tail dot head. In this case, you don't have to count all the tails because you know a dot tail is gonna just point to a list that's like self-referencing. So it's gonna be what?
7.
Yeah, it's gonna be 7. So correct answer is 5977. Any questions? Congrats. Okay. So for these kinds of questions, you have to get very comfortable with being able to count your tails and being able to like manipulate your boxes so that you can like redraw pointers. And it's just really a lot of practice that goes into it. Does anyone have any questions? No questions? Okay. Okay, then you guys can take another 6 minutes, try get an idea of what you have to do. So what I mean by an idea of what you have to do, I highly suggest you draw a list that looks like this.
Oh, instead of what they gave us.
No, because we're just going to go 2 at a time, right? Because we only like do that. So it's kind of like a very incremental sort of crossing over. So think about what you have to do to get this to look like that instead. And notice that they're like, hey, you should initialize a pointer of some sort here. So why do you need that pointer?
Can I ask?
Mm-hmm.
Is this a dot tail or is this a just?
So this is just A. So this is A.
Yeah, and then.
So A points to this. So like it's like the same as saying that.
Okay, so that's not a dot tail.
Right. Same thing.
Cool.
Yeah.
And the question marks on A and B, like after just means they don't care. Like,
Right. They're just like we don't know where A and B ended up. Let's go over it. But before we go over it, let's build some intuition for how to move our pointers. So I gave you guys this and told you guys to think about how to move like this to here and that from there. So let's start with the original list. So if I want to get the pointer to go here, what call do I have to make? Sure, so a dot tail equals b dot tail. So then this is going to happen. Does anyone see anything wrong?
Nope.
There's nothing pointing to anyone.
Yeah, there's nothing pointing to this anymore. So we need to keep track of this somehow. How do we keep track of it? Yeah, we use T1. So we need to save a dot tail with T1. So that's already what we can glean. So if we have some T1 pointing here, then we're fine. We still have our list. Okay, so then what's the next thing we want to do? Right, so we want to make b dot tail equal T1, because we want b to cross over here. So I'm going to do that. This pointer is going to go away, and we're fine. But this is just a case of like a 2-link list, or 2-int list, like length list, right? So if I have stuff over here, what do I have to do? Well, is it a dot tail?
Or it doesn't really matter.
No. Should a be a dot tail?
It should be T1.
Right, it should be T1. Because we still want to move horizontally. Because we're kind of like incrementally crossing over the links. So a will be T1. And then what will b be? Yeah, it'll be a dot tail. So, right? Because a dot tail is pointing to the next element of b, and that's the next one we have to process. So,
Is that entirely necessary though?
is it?
Because if you, let's say you set A to A dot tail and B to B dot tail, like it'll flip flop, but like you don't really care where A is pointing to.
Let's see.
So then
So
at
I
that
set a to be a dot tail.
Yeah.
Okay, so I make a go here, and then I make b go here.
Yeah. And you're still
Then
within the list.
yeah, actually, yeah, that might work. Yeah, sure. So I think you can do it either way. You'll just have some flipping behavior. Yeah.
So if you set A to T1, then never mind.
Okay. Was your question like, should you set a to T1 instead of a dot tail to T1?
No, I was wondering if you could do like A equals like B dot tail and then.
Oh, like the simultaneous assignment?
Or I mean, no, like right after each other, but you could set A equals B dot tail. And then
Right.
B dot tail.
Okay, yeah.
So wait, you do it in that order, right?
Yep. So we can just write it in, where T1 is a dot tail, and then we say a dot tail equals b dot tail, and then a equals T1 and b equals a dot tail. Oh, whoops, did I forget a statement? Oh, my bad, forgot b dot tail. Okay. Okay. Any questions about this? Any questions? So, I think this is like a less crazy version of that braid problem if you guys want to grill this section. But, yeah, get comfortable with doing this kind of stuff. Now we can we move on? Okay, so now let's do, where's my cursor? Okay, let's do inheritance. So, this one is a bit tricky, and it's a bit tricky because all you have are these 4 lines, but these 4 lines at first seem quite ambiguous. So, my advice to you for this problem is dissect what each line tells you if it compiles and runs, and you don't get like an error. How do you feel about this question? Huh? Too confusing? Yeah, this is the hardest question out of the set, I'll say. It's very tricky in that I don't know. This is like not that intuitive in my opinion. But first, we'll just do a little review of inheritance, and that when I have this kind of relationship going on, where dog extends animal. So first, we'll define an edge as like if I have an edge like V to U, then that means U extends V. Yeah, inheritance. Okay. So when I have animal to dog, so dog extends the class animal, what we're establishing is that all dogs are animals. However, not all animals are dogs. And that makes sense, right? Like, you have otters that are not dogs. So that should give you some intuition for statements like this. Why? Because we're saying something of static type A can be an object that is of class C, an instance of C. So for this question, what I found to be most helpful was to break down each line and what implications it had about the class inheritance relationship. So just like I said from A equals new C, because that compiled and ran, what does that mean?
C extends A.
Right. It means that there's some level of hierarchy where A is greater than C in the hierarchy. So like A is above C. Why? Because A is more generic than C, so that you can have something of C be assigned to a static type of A. Does that make sense? Okay. So then, now when I say bx2 equals x1, what we have to remember is that x1 has a static type A. So because this compiles and runs, so for this, I'm just assuming it compiles and runs. What relationship does that tell me? B is greater than A. Why? Because we're able to assign something of static type A to something of type B. So that means we're saying all A's are B's. All dogs are animals. So that's what that kind of assignment is telling you. So if I replace A with animal and C with dog, that makes sense. And then the other way doesn't make sense, where I say A is dog and C is animal. Yeah.
So in line 2, we say dx2 equals x1. We're comparing static types because
We're not casting. We're not casting. So that's why we're able to just compare static types. Okay. So that means B is greater than A because it compiled. Hurrah. And actually with this, now you have enough information to solve the first one because you have all of your elements, you have a hierarchy, and that's just A goes to C and B goes to A. Why? Because we had enough information. These two inequalities gave us all the information about the inheritance. So when I draw a diagram like this, what I'm saying is that C extends A and A extends B. Yeah.
So when you're casting, aren't you usually casting from a super class or subclass?
Yes. Usually you do it to get more specific, but you could cast the other way.
You can.
Right? Remember when you did generics, generic arrays, where you made an array of an object class and you would cast upwards? Kind of weird. Yeah. So you can do both ways of casting, but it's kind of just, I think it's more intuitive to think about, to not let that hinder your understanding of casting. Casting, you can just tell this is that type, and the compiler's okay. Sometimes. Other times it'll be what are you talking about? But yeah, any other questions? Yes.
If on the exam you didn't write C extends A or A extends B, would the diagram be enough?
Yeah, I think the diagram would be good enough. So this is a standard inheritance diagram, right?
So casting always works, except at runtime you might get an exception, but you won't complain at compile time.
At compile time, it can complain.
Like
It can complain if you're trying to cast two obviously very different types, right?
okay.
What if you're this animal is now a bush? The compiler would be what are you talking about?
Okay.
Yeah.
So if it doesn't obviously
Right.
Okay.
So if it doesn't inherit, you can't cast it.
Okay.
That's why you can cast everything to an object, because like the object is like the class that's the parent of everything. Okay, so now let's move on to part B. Part B is telling us that the code in part A fails to compile, but it will compile if we remove the second line.
Yeah.
What does that tell you about this relation? So this is if it compiles, and if it no compile,
B is not the superclass of A. A is greater than B.
right, it means A is greater than B. Why? Because it's just kind of like the relation is turning itself around. You're like negating it. Oh, actually, yeah, so in this case, it's irrelevant, but you have to be able to negate the fact that B is greater than A, and the only like other half of that space is A being greater than B. Does that make sense? So like what it tells you is that B is not greater than A, which is the same as A being greater than B. Yeah.
But if that was the case, wouldn't it not compile as we cast it in line 3? When you try to cast
In line
the
3?
next one is
Well, okay, so line 3. Line 3, we're trying to cast. So the thing is that when you're casting, I think my understanding is that you're casting the whatchamacallit, you're casting like the instance of the object. So I don't think you're casting the static type. Anyone can correct me on this, but my understanding is that when you cast like the instance type instead of the static type. Yeah.
I don't know how much this matters, but like for Java, the subclass usually points to a superclass, right? Like,
Does
that's
it?
how we were taught.
Was it?
Pretty sure, like
I
the
mean-
documentation's always like that.
Okay, we can do that. Oh no, which way did my arrows go? That way and that way? Okay. So then let's just switch these around.
only the arrows.
I mean, I think both of these like
U extends V. So U goes here and V goes here. Okay. Alright, sorry. Okay. So because we said that line 2 failed, we get this relation. And then over here we're saying that, oh, we can cast C to B. Right? We can cast the type C to B because X1 is of like dynamic type C. So this just means that type C can be cast to B. I remember I'm pretty sure you just cast up. Because you're casting like, whenever you do cast, I'm pretty sure, like, unless it's like with floats and like doubles, you kind of cast upwards instead of casting downwards. So more generic. Yeah, more generic.
Can you cast downward for it to compile though? Like
You can cast.
You know it's a.
Yeah, if you know it is.
Yeah.
But generally you cast
Okay.
upwards. So, but you just say here that type C can be cast to type B. And then if we draw in our boxes,
Nice.
B is greater than A, if A is greater than B, and A is greater than C, we know that A is kind of like at the top of the hierarchy. So now we have to just figure out the relation between B and C. So that brings us to our fourth line. So this line doesn't really tell us anything except that you can cast it. And if you get a runtime error, then it's like you did a bad cast. But the fourth line tells us that, X1 is already like of type C, right? So this is just, what relation is this giving you? Right. So we get this relationship where C is going to B, which is going to A.
So is all casting dynamic in Java?
I'm pretty sure casting is on the dynamic type. I will check in with that. I think it makes sense in this. So, is it static type?
So what's that? Yeah. The reason was there.
But then if you can cast type A to type B, that's telling you that.
Yeah.
Okay. So casting is static type, but in this case, casting
is static type.
casting is static type. Yes.
Wait, we got it.
Right. Although if you run, you can get like a class cast exception, which can happen.
I might just want to test you maybe.
But
Yeah.
yeah.
So when you're casting from, and you have like, for the CBA, if you try to put B into C without casting, it should not compile.
If you try to put B into C, no, you can say, or
But you'd like have to cast.
yeah, you have to cast B as a C. Right. Because C is not generic enough to cover all B's. Okay. In this case, I don't think it really matters whether casting is static or... Although it does say that here type A can be cast to B. Right? And then this is telling you that type A can be cast to C. That makes more sense. So I'm pretty sure casting is just static. So all static types. So that's before you run the program. Yeah.
Wait, so when you cast x1 to b, shouldn't it cause an error because x1 is like static type as well?
No, because you're just telling the compiler this is actually B. Because remember, you can have something that's like more
So you're
generic.
telling the compiler to ignore basically?
No, just treat it like it's type B.
Okay.
Okay. So we still get this relation. Because we know B is greater than C, A is greater than C, and A is greater than B. So you get...
Can you explain why B is greater than C again?
Because
So you said it
here
casts-
we cast this to type C, and we were able to shove it into B, which means B is more generic than C.
Okay.
Wait, so does casting work both ways?
Yeah, I think casting is just, you tell it, and it's like, okay. And then you worry about it during runtime.
Yes. You can cast both ways, but at runtime it causes errors.
Yeah.
It's not just
Okay, so let's do the last part real quick before I let you guys go. Now it's saying that when you remove the second and the fourth lines, it'll compile, but it'll cause a class cast exception. So if we remove the second and the fourth lines, that means here for no compile, we're saying that C is actually greater than B, right? Because we're just flipping it if it's not compiling. So then we have the relations A is greater than C, A is greater than B, and C is greater than B. So then we get C